Welcome to the MecSoft User Spotlight series, where you can find real people using MecSoft products. In this video, we'll be spotlighting Calton cases and the use of RhinoCAM software. Calton Cases, located in Austin, Texas, manufactures custom-fit musical instrument cases through a worldwide network of instrument dealers. Keith Calton started the company in 1969, handcrafting well-made, nearly indestructible cases for devoted musicians and collectors. As Keith put it, for quality and endurance. With the help of CAD/CAM and CNC machining technology, the company that Keith founded is still thriving today, and the cases they produce really are, well, nearly indestructible. Calton Cases manufactures cases for 10 different lines and 350 different types of musical instruments, each custom fit to the customer's exact specifications. The 10 instrument case types the company manufactures include electric, acoustic, bass, archtop, banjo, mandolin, bouzouki, ukulele, violin, monticello, and more. The CAD/CAM technology. Anthony Pelosi has been with Calton Cases for 10 years, first as a fabricator, then as a CNC operator, and now as a product designer and innovation lead. Anthony started his career with a 4-year degree in Asian Studies, but with a love of music and being good with his hands, he started manufacturing musical instruments for various companies. He soon became a hands-on fabricator of many different skills, so he decided to go back to school and take some drafting classes. Today, Anthony is spearheading the use of CNC technology at Calton Cases. His CAD software of choice is Rhinoceros from McNeil & Associates. The CAM software that Anthony relies on to run his 3-axis Laguna CNC machining center every day is RhinoCAM from MecSoft Corporation. We recently sat down with Anthony to discuss his use of RhinoCAM software. Here is some of what Anthony had to say about RhinoCAM.
I was up in machining parts in a couple of days, and this was me just figuring it out on my own. Now, it's just amazing what you can do with the software.
Thanks, Anthony. The mandolin case, beautiful and durable. Anthony walked us through the process of creating a Calton case. It begins with 2 mold cores. The cores are machined from high-density polyurethane, similar to modeling board. The 2 cores are then used to thermoform 1/8-inch thick textured ABS cavities, one for the top and one for the bottom of the case. The textured ABS cavity forms are then used to lay up the actual top and bottom case components from durable, multi-layered reinforced fiberglass. We should interject here that when Keith Calton started the company in 1969, these cores were hand-carved and hand-textured in a process that took up to 2 weeks. Today, Anthony can produce a production core mold in 1 hour. The interior of the case is outfitted with cloth and foam inserts, fitting the customer's exact mandolin's dimensions. The outside is fitted with labeling, hardware, and sealing that protect the instrument from all weather conditions. The end product is a sturdy and durable case that provides lifelong protection to the instruments enjoyed by the musicians and collectors alike. Here is the mandolin case in blue silver from Calton Cases. Machining the mandolin case core molds. The master CAD/CAM part file for the mandolin case mold cores is shown here in Rhino 6. It contains the 3D models of the top and bottom core, as well as interior instrument templates and other CAD data. An entire mandolin core measuring 18 inches by 35 inches is machined from a 3D polysurface model requiring only 2 RhinoCAM toolpath strategies. The only RhinoCAM selection is a simple 2D rectangle used to contain the outer boundary of the toolpaths. For bulk material removal, a 3-axis horizontal roughing toolpath is used. This removes material in Z levels. Finishing is performed with one 3-axis horizontal finishing toolpath. After coming off the CNC machine, the cores are lightly sanded and then given a spray of coating to withstand the temperatures of the thermoforming process. In the Rhino 3D part file, we see that the RhinoCAM machining browser is displayed on the left, with the roughing and finishing operations listed in the machining job tree. The current tool library is also shown below. Here is more of what Anthony had to say about RhinoCAM.
I just have to say that I do believe, and this is why I still use it, is that RhinoCAD and CAM for Calton cases, it is a genius that works for us.
Thanks, Anthony. Let's take a closer look at the toolpath strategies used to machine the mandolin core molds. Here we see the Rhino 3D part on the left and the workpiece stock shown displayed on the right. Here we see the 3-axis horizontal roughing toolpath and cut material simulation. This bulk removal strategy removes material in multiple Z levels using a 3/4 inch diameter flat end mill. The last Z level includes a finishing pass on the flat bottom surface. Next, we see the 3-axis horizontal finishing toolpath and cut material simulation. You can see that the finishing strategy automatically cuts the vertical tapered sides and the contoured top of the core using a 1/2 inch diameter ball mill. The 1/4 inch radius at the base of the core is machined automatically. With the top mold core complete, machining the bottom core is a one-click process. Just display the bottom core, right-click, and regenerate the toolpaths. RhinoCAM does the rest. It really is like magic. Smart Finishing in RhinoCAM Standard. The 3-axis horizontal finishing toolpath strategy for the top mandolin case core is shown here. It illustrates the use of the optimized machining controls provided by this toolpath. Because horizontal finishing is a toolpath strategy that cuts in horizontal planes, it is primarily used for near vertical walls, like the tapered sides of the mold core shown here. However, near horizontal areas like the contoured top of the core would normally require additional remachining operations due to the wider offsets created by the horizontal planes. The uncut stock is clearly shown here on the right. With optimized machining enabled, additional toolpaths are automatically added between Z levels to allow full and complete finishing of the core in one operation. The optimized toolpath is shown on the left. The complete material removal, sides and top, is simulated on the right. RhinoCAM also allows you to control the step over and engage retract paths in these optimized areas, as shown here in the optimized machining dialog. Here is more of what Anthony had to say about RhinoCAM.
A problem that you think might take you a week to figure out, there's a 2-minute answer to. I don't want to be on a forum or a help list for half a day trying to find the answer I want. I want to be able to email someone who is there and ready and willing to help me with the software. And it's a relationship, and RhinoCAM has done that.
Anthony loves his RhinoCAM. Let's have a look at the cut material simulation of these two mold cores. And the best part about optimized machining is that it's available in RhinoCAM's standard configuration. We want to thank Anthony Pelosi and the team at Calton Cases in Austin, Texas, for allowing us to showcase their work. To learn more about Calton Cases, we invite you to visit them at their homepage, Instagram, Facebook, and on Pinterest. RhinoCAM is available in 5 configurations: Express, Standard, Expert, Professional, and Premium. The parts shown here were programmed using the standard configuration. Here are some additional details about each configuration. With a complete features list, we invite you to visit the RhinoCAM product page. This video was brought to you by MecSoft Corporation, your CAM partner.